When we talk about inequalities, first we need to discuss what is an inequality. Inequalities use the symbols less than or equal to, greater than or equal to, less than, or greater than. You can tell these apart by if it includes equal to, you'll see half of the equal sign. And so, for example, 9 is greater than 7. And remember that the bigger opening indicates the bigger quantity. 7 is less than 9. 9 is greater than or equal to 9. And 7 is less than or equal to 7. What if we have a variable? So what if we have the inequality x plus 5 is greater than or equal to 7? Well, when we had an equation, x plus 5 equals 7, this was asking, what is the value x that makes the statement true? The same thing is true in the case of inequalities. We are asking for what values of x is this inequality true. So in the case of an equality, the solution is x equals 2, which is one number. However, in an inequality, this is true when x is greater than or equal to 2. So if we look at these on a number line, for an equality, our solution is 1 point, one value. But for an inequality, we have many values. So because this includes equal to, we have a closed dot, as well as everything greater than 2. So linear inequalities have many solutions, while linear equalities only have one solution. So let's solve an inequality using the rules for inequalities. So if we are going to solve this equality, we would subtract 5 from each side to get x equals 2. So can we do the same thing with an inequality? Can we subtract 5 from each side? If we just looked at 6 is greater than 3, what would happen if we were to subtract 2 from each side? Is 4 still greater than 1? Yes. What if we added to both sides? So if we had 6 is greater than 3, and we added 2 to both sides, is 8 greater than 5? Yes. It's always true that if we add or subtract the same quantity to both sides of an inequality, that we get an equivalent statement. So we can subtract 5 from both sides so that we get x is greater than or equal to 2. And we write solutions to inequalities in interval notation. So if x is greater than or equal to 2, we have a closed bracket around 2. Closed indicates that it's included, and we can go all the way to infinity. And plus or minus infinity always gets an open bracket. So this is true from 2 and including 2 all the way up to infinity. And we can write our solution again on a number line. Again, because we include the value 2, we have a closed circle, and we shade in everything greater than 2. What about 2x minus 3 is less than or equal to 9? So solving the equality, we would add 3 to both sides to get 2x equals 12. And we just learned that we can add the same quantity to both sides of an inequality and get an equivalent statement. So we get 2x is less than or equal to 12. And now, to solve the equality, we would think of this as either dividing by 2, or we can think of it as multiplying by 1/2. And now we need to ask, can we do the same thing with our inequality? Can we multiply 1/2 or divide by 2? And will we get an equivalent statement? If we have 2 is less than or equal to 6, what happens if we multiply each side by 1/2? We get 1 is less than or equal to 3. which is true. What happens if we multiply each side by 2? We get 4 is less than or equal to 12, so that's true. What happens if we multiply each side by -2? Then we get -4 is less than -12. Is that true? If we look on a number line, -12 is less than -4. So we need to flip this inequality. We have -4 is greater than -12. And similarly, if we have 2 is less than 6 and we multiply each side by -1/2, then we get -1 is less than -3, which is not true. Again, we have to switch this sign. -1 is greater than -3. So if we multiply or divide by a positive number, then that's fine. But if we multiply or divide by a negative number, we don't get an equivalent statement. We have to switch our inequality sign. So going back to our equations, we get x equals 6 for our equality, and for our inequality, we get x is less than or equal to 6. So let's look at what this looks like on a number line. So we include 6, and we go everything below. X is less than or equal to 6. So if we write this in interval notation, we include 6, and it goes all the way down to -infinity. So -infinity with an open bracket to 6 with a closed bracket. So let's write these rules that we learned formally. So our first rule was if we're adding, that if A is less than B, and this is true whether this symbol is less than or equal to, greater than or equal to, then if we add a quantity to each side, we get an equivalent statement. We also learned that if A is less than B, then we can subtract a quantity, the same quantity from both sides, and we get an equivalent statement. We learned that if A is less than B and our quantity C is a positive number, then when we multiply or divide by C, we get an equivalent statement. We also learned that if A is less than B but C is less than 0, so it's a negative number, then when we multiply by C, we have to switch our inequality sign. There are two other rules we need to know. First, if both A is greater than 0 and B is greater than 0, so they're both positive numbers, and A is less than B, then 1 divided by A is greater than 1 divided by B. So let's think about why this is true. So if we know that A is less than B, so to make this look like 1 divided by A and is greater than 1 divided by B, first we're going to divide each side by A. And this, we know A is greater than 0, so we don't have to switch our inequality. So we get 1 is less than B divided by A. Now we're going to divide each side by B. Or we can think of it as multiplying by 1 over B. And so we get 1 divided by B is less than 1 divided by A, which is what we wanted. Our other rule that we need to know is that we can add two inequalities together. So if A is less than B and C is less than D, then A plus C is less than B plus D. So for example, if 2 is less than 4 and 3 is less than 5, then 2 plus 3 is less than 4 plus 5. Let's solve the inequality 2x is greater than 5x plus 6. So the first thing we want to do is get everything with an x on the same side. So we can subtract 5x from each side so that we get negative 3x is greater than 6. Now we're going to divide by negative 3, and we're dividing by a negative number, so we have to switch the sign of our inequality. So we get x is less than negative 2. And we can graph this on a number line. And we just have less than, so we do not include the 0.2, so we use an open circle. And it's less than, so we shade in everything less than negative 2. And to write this in interval notation, we have an open bracket at negative 2, because it's not included, all the way down to negative infinity. Here we have the inequality, 6 is less than or equal to 2x plus 4, which is less than 10. So really, we can think of this inequality as two separate inequalities if we wanted to. We could think of this as 6 is less than or equal to 2x plus 4, and 2x plus 4 is less than 10. So we could solve these separately or together. So I'll show you both ways. So first, we want to get x by itself, so we're going to subtract 4. So if we were doing these as two separate inequalities, we'd subtract 4 in both cases. So we'd get 2 is less than or equal to 2x, and 2x is less than 6. Then we divide by 2, and that's a positive number, so we don't need to worry about switching the signs. So we get 1 is less than or equal to x, and x is less than 6. So putting these on a number line. So first, x is greater than or equal to 1. So we include 1 and everything above that. And x is less than 6. So that's an open circle at 6 and everything below that. But we need both of these to be true. So our answer is only the things that are shaded in both colors. So our answer is 1 all the way up to 6, but not including 6. So writing this in interval notation, remember these are both. So writing these in interval notation, we have a closed bracket around 1 up to 6 with an open bracket. So we could have solved this without writing these as two separate inequalities. So to do that, we knew that we needed to subtract 4 from each side. So we're going to do that to each of the 3 parts. So we get 2 is less than or equal to 2x, which is less than 6. Then we wanted to divide each side by 2. So I divide each of my 3 parts by 2. So what we do to one part, we have to do to all 3. So that gives us 1 is less than or equal to x, but less than 6. So we get the same answer. So now you try solving this inequality. Negative 2 is less than or equal to negative 2x plus 4, which is less than 6. So pause, try it on your own, and then check your answer. So to solve this inequality, we want to subtract 4 from each of our parts. So we get negative 6 is less than or equal to negative 2x, which is less than 2. So now we divide each side by negative 2. And since we're dividing by a negative number, both of our inequalities need to switch. So we get 3 is greater than or equal to x, which is greater than negative 1. So putting this on a number line, we know that x has to be greater than negative 1, but not including negative 1. And x has to be less than or equal to 3, and it can include 3. So now we look at where our colors overlap, and we see that we get negative 1, but not including negative 1, all the way up to 3 and including 3. So in interval notation, our answer is -1 with an open bracket to 3 with a closed bracket. And we could check our answer. What if we plugged in 2? 2 is between -1 and 3. So if we plug in 2, we should get a true statement. So -2 is less than or equal to -2 times 2 plus 4, which is less than 6. So is 0 between -2 and 6? Yes, that's true. So far we've only talked about linear inequalities, but now we're going to talk about nonlinear inequalities. So what if we have something like x squared is greater than -5x minus 6, or x plus 1 divided by x minus 1 is less than 0? So first, let's think about the question, when is a times b less than 0? So we know that if a is positive, so if a is greater than 0, then if b is greater than 0, then two numbers multiplied together give you a number that is positive. So then a times b will be greater than 0. But if b is less than 0, then a times b will be less than 0, because a positive number times a negative number gives a negative. On the other hand, if a is less than 0, then if b is greater than 0, a negative times a positive will give us a negative. And if a is less than 0 and b is less than 0, then two negative numbers multiplied together give a positive. So it's a times b is less than 0 when a is greater than 0 and b is less than 0, or when a is less than 0 and b is greater than 0. And the same thing is true with division. So we're going to use this idea to solve nonlinear inequalities. So in the case of x squared is greater than -5x minus 6, our idea is to get this as numbers being multiplied together and then a 0 on the other side. So first let's get 0 on one side. So let's add 5x plus 6 to each side, so that we get x squared plus 5x plus 6 is greater than 0. Now, to get this left-hand side to be two things being multiplied together, we're going to factor. So we get x plus 3 times x plus 2 is greater than 0. So now we need to know, when are these two quantities, x plus 3 and x plus 2, multiplied together? When are they greater than 0? So to do that, first we're going to find where they are equal to 0. So we're going to find that x plus 3 equals 0 at x equals -3, and x plus 2 equals 0 at x equals -2. Then we're going to put those on a number line. So we have -3 and -2, and we're going to make a sign chart. So we're going to put our factors on the left-hand side. And so we want to know, in each of these intervals, are we negative or positive? So x plus 3, if we pick a test point like -4, x plus 3 is going to be negative, and x plus 2, so -4 plus 2 is still negative. If we pick something between -3 and -2, like -2.5, -2.5 plus 3 is positive, -2.5 plus 2 is negative. Something greater than -2, like 0, gives us positive and positive. So remember what we said about two negative numbers being multiplied together gives us positive, and negative and a positive multiplied together gives us a negative, and a positive and a positive multiplied together gives us a positive? Well, we're going to use that idea now. So if we look at what x plus 3 times x plus 2 gives us, we get negative times negative is positive, positive times negative is negative, and positive times positive is positive. So this means we are looking for where we are greater than 0, so where we're positive. So that happens when x is less than 3 and x is greater than negative 2. And we do not include negative 3 or negative 2 because we just want strictly greater than. So our answer is negative infinity to negative 3, and we use a u for and, negative 2 to infinity. Now for quotients, we can do the same thing. So this is already, we have 0 on the right by itself. So we're going to determine what values make this 0. So that's at x equals negative 1. And the value that makes x minus 1 0 is x equals 1. We should also note that this inequality can never equal 1 because 1 gives us a 0 in the denominator, so it's not in our domain. We put these on a number line, so we have negative 1 and 1. We put our factors on the side, so x plus 1, x minus 1, and then we do our sign chart. So if we test something less than negative 1, like negative 2, negative 2 plus 1 is negative, negative 2 minus 1 is negative. Between negative 1 and 1, we can test 0, so we get a positive and a negative. Between 1 and infinity, we could test 2, so 2 plus 1 is 3, which is a positive, and 2 minus 1 is 1, which is a negative, or which is a positive. So now what happens if we divide a negative number by a negative number? We get a positive number. If we divide a positive number by a negative number, we get a negative. Dividing a positive by a positive gives us a positive. So we want to know where this was strictly less than 0. So that's between negative 1 and 1, not including the endpoints. So in interval notation, we have open bracket negative 1 to open bracket 1. We want to solve the inequality x squared times x minus 1 is less than or equal to 0. So this inequality is already in our form where we have things being multiplied together, which is less than or equal to 0. So we want to find where this is where each of our factors on the left is equal to 0. So x squared equals 0 at x equals 0, and x minus 1 equals 0 at x equals 1. So now let's draw our number line. So we have 0 and 1, and notice that this is x squared and not just x. But that's okay, we can leave it as a squared term, as a repeated factor in our sign chart. So notice that if anything's squared, it doesn't matter whether we're squaring a negative number or a positive number, we're always going to get a positive number. But with x minus 1, we're going to need to test points. So if we test negative 1, we'll get a negative number. If we test 0.5, we'll get a negative number. And if we test 2, we'll get a positive number. So for x squared times x minus 1, less than 0, we have negative. Between 0 and 1, we have negative. And greater than 1, we have a positive. And we wanted to know less than or equal to 0. So we are negative if we are at the point 1 or less. And we are including 0. So interval notation, we have negative infinity to 1 with a closed bracket. But here's an interesting question. What if this was strictly less than, not equal to? So then we would have to not include the point 1 or the point 0, because that is where we are equal to 0. So then, in interval notation, we would have negative infinity to 0, not including 0, and 0 to 1, not including 1. Let's solve the inequality x squared is less than 9. So we need to get 0 on one side, so we're going to subtract 9 from each side to get x squared minus 9 is less than 0. Now we need to factor, so we have x minus 3 times x plus 3 is less than 0. We find our zeros, that's at x equals 3 and x equals negative 3. We put those on a number line. We write our factors on the left side. And then we're going to create our sign chart. So testing a point less than 3, like negative 4, we get a negative and a negative. Between negative 3 and 3, we can test 0. So we get a negative and a positive. And greater than 3, we could test 4. So we get a positive and a positive. So then looking at our factors multiplied together, we get a positive if we're less than negative 3. We get a negative between negative 3 and 3, and positive greater than 3. And we just want where we are less than 0. So that is between negative 3 and 3, not including the endpoints. So in interval notation, we have open bracket negative 3 to open bracket 3.